Hi, I wanted to talk to you about security. Computer security is very important, and sometimes it is easy to do things on the computer which are not legal, perhaps not moral or ethical. So, why would we not do something that's perhaps easy? Well, we wouldn't do that because it's wrong. In fact, in the physical world, we see a lot of things that are perhaps easy to do. We can take a stone and throw it through a window at the mall and gain access, which is unauthorized, but it doesn't mean that just because it's easy, we should do that. So while things are easy on the computer, we have the same legal and ethical considerations. Now, everything on the computer is based on layers of security. And the first layer is physical security. If you have access to a Unix computer, you can reset the administrator's password. In fact, even on a Windows computer, given enough time, you can do that. So let me show you here a lock. This is a standard lock which would be used in many environments to physically secure. So how can we assess security of this kind of a lock? Well, locks are not all the same, and some have more security features than others. For the needs of this demonstration, I will use this training lock, which allows us to see inside of it. What we have in this lock are a set of pins, and you can see the pins here. These pins are under tension from springs, and each one of these pins is actually made out of two elements. The two elements is a bottom a pin and the top pin, and they will meet at a certain point, and this line where they meet across would be the shear line. So when all the pins meet at the shear line, then and only then the lock is going to turn. You can see that all the pins have leveled off, and now the lock will turn, and we have unlocked this particular system. So what would be the weakness of this particular lock? Well, there are two movements that cause this lock to unlock. One is we have to turn physically the pin around. The second part are the notches on the key, which will level off the pins and therefore create the shear line across, and we will be able to turn. So what's actually possible is we can put in a physical object into the lock, and you can see how one by one the pins are jumping. Now the first pin is jumping, now the second, the third, the fourth, fifth, right down to the sixth. And this actually can be recreated with other tools than just the key. So let's see how this might happen. Well, I'm going to use two tools. The first one is called the tension wrench, or otherwise a torsion wrench. And this simply is going to allow me to create the circular movement to do the first step, the first movement. Of course, this tool all by itself is not going to do the trick. So the way this works is we would just insert this type of a tool and then provide tension. And what the tension allows is it creates just a very small movement of the middle plug, and as I am applying the tension, each one of the remaining pins is going to also start sitting right on the edge of the hole that otherwise it's occupying. So that's the first step. The second step is applying this hook, and specifically this is a hook pick. There are multiple types of picks depending on the lock. So sometimes in movies you will see perhaps someone taking a little pin out of their hair and trying to open a lock. It will be really difficult to do with just a single tool. Most of the time you require two tools. And by the way, this is not just for breaking into places, but locksmiths actually polish these skills in order to enter um or break locks or unlock them when the owner lost the key or otherwise the key cannot be located. So how does this pick work? Well, I can insert the pick into the lock and now manually uh, move up and down each one of the pins. So here's the first pin. You can see how each pin is made out of two cylinders and they meet in the middle. So I can move the second one, the third one, and each one can be moved separately. There isn't a lot of room to work here, so a lot of this is based on the feel. Of course, an actual lock is not going to be a see-through, it's not going to be transparent, so the feel of it is really what we would go by here. Okay, so let's see how this works in conjunction. So we'll go ahead and insert the tension wrench, and the idea here is to hold the lock and then apply the tension at the same time. Notice that the tension wrench just allows me to turn the lock very slightly, and when I do that, the tension is applied, and each one of the pins now has a little force that is exerted on it. And all I have to do with my pick is simply lift each of the pins up so that they start sitting on the edge of the plug. So as I'm applying the tension, I am sitting each of the pins on the very edge. And if I pick each of those pins up, all right, and I keep applying the tension, notice what happens. My tension wrench now turns just like a key would. And you can see, you can see the second part of each of the pins as they have been leveled across the shear line. And as I apply the tension, the lock unlocks. Okay, so this didn't take a long time. You can see the pins are now reset in their random setting. The idea is that each key would be slightly different, and as you insert the key, the pins are then leveled. So I hope that this shows you that physical security, just like any type of security, has its limitations, and it doesn't take very long to figure out how to circumvent, and often for legal reasons, security. But again, this does not mean that just because it's easy to do, it should be done. We have ethical considerations and legal considerations in place. Thank you.